Like Tony mentioned, we'll see if this works and if I trip over it. My name's Jack, and back at the last Hack and Tell hosted by Ryan, I wanted to put together a pretty simple, really simple compared to what we just saw. Everything here is going to be really unimpressive compared to what we just saw. A really simple app to look at air quality around the world. Ideally one that would look kind of like a weather app on your phone. And so there were a couple of considerations that went into that, which is kind of what I want to walk through today, especially PWAs. So I'm Jack. The reason for why air quality is that I studied environmental science and Chinese in college, and so that obviously leads to questions about air quality and how it gets measured. And there's a really cool open source project called OpenAQ, which conveniently, exactly a year ago, I did a quick lightning talk on for the same group, which was just about that project and how they collect data and who's working on it and what the various aspects of it in terms of APIs and UIs are for OpenAQ. So I'll mostly be skipping over that today and just talk about here's how you use it in a project. So the basic summary, first we'll take a quick look at the app. I'll see if I can display it. And then kind of the four aspects of it that I think are worth talking about. Quickly, the data that's used for it. Then TypeScript, because I think TypeScript's really cool. And I know a lot of people here for good reason like React a lot, in which case you're probably not going to move over into an Angular app. So you'll kind of gloss over number 4 there. But I would highly recommend TypeScript for anyone. And I want to talk through how that can kind of work for a small scale app like this. And then lastly, PWAs. We'll do it this way, raise your hand if you know what that stands for. Okay, so there's at least some people. Cool. It stands for Progressive Web App. We'll get there. The app is this, especially if you have Android. Feel free to visit that. I'm going to try real quick to pull it up here so we can look through it from the device. Or why don't we just play it safe? So this is a very simple mobile-first web app, which would look kind of like this on your phone. And it's just so far for searching by cities. Oh,
it's tough.
You know, you can tell. Thanks, appreciate it. What's going to be the easiest way to do this? I'll just make it small. Wow, this is really small. You weren't seeing much of the presentation then, were you? Okay. Well, we'll go with this for now, and we'll get back to how we handle presentation. So it's just to search by cities, and based on what OpenAQ provides and which measurements they track, which are research grade or government grade data about air quality, you can start typing and you get the available ones. So we see Milwaukee. I wanted to keep it as simple as possible, like you would a weather app, visually indicating, and then this is just the simple overall AQI air quality index score for a city, which is based on multiple different parameters. In this case, there are 3 tracked for Milwaukee. It's just the different criteria pollutants that make up how good or bad air quality is. So, shockingly, if you search Shanghai, where I lived for a little while, not quite as good. And if you search Mumbai, odds are also not quite as good. And you can tell that Shanghai, it's just tracking this PM 2.5, which is kind of the big cancer-causing one. Mumbai has a lot. India has a lot of tracking that they make available. And so far, this is pretty much it. The next steps are to be able to choose ones that you want to choose cities that you want to save so that you can come back to them like a dashboard, which cities are you interested in, and then also to compare over time because they OpenAQ does make time-based data available. But there's a little bit more in terms of functionality of how you can use this thing, which is where the progressive web app comes in. So does this Ugh, wow. All right, we'll just see how this looks. I'm worried if I spend too much time trying to fix it that we'll all get sick of it. So that's the app. We'll get to the part of why it's progressive near the end. OpenAQ, I'm not going to go to the site, but if you look at OpenAQ, they are open source. They maintain APIs for getting the data, also methods for pulling from research stations or government locations, and then just worldwide air quality records that they make pretty easily accessible. This is where, so the question for building something like this, which I think might be relevant for people, is if you want to make something fairly quickly and fairly simply, but you want it to be very easily usable, with something that's new, with something that you're not used to, this is where I found TypeScript to be super useful. TypeScript is a subset. It compiles down to JavaScript, and it allows you to have static typing for your JavaScript so that you can see what methods and properties are available on the things that you're working with, which I found to be super useful when you're starting a new project and you're not really aware of the methods that you kind of have access to. So that's where scalability, obviously, in order to type things, it also allows you to share code super easily with other people so that you know that this method is expecting these inputs, and especially when partnered with Angular, it leads to really easy and at least in my opinion, very easy and well-styled architectural decisions, I think. So, okay. So actually at Hack and Tell, one of the things we got done pretty early is that we wanted to type the available methods that OpenAQ has. So they have information about their API, and they tell you what they're expecting as inputs, country, order by, sort, and what you'll get back as outputs, city, country, count, and locations. And so we went through and we replicated that. I think we were just looking at cities, right? So we have a request model and a response model, and we have a very simple method to actually go and get cities by hitting the Open API URL. And what that means in the end is that it becomes extremely easy to hit that endpoint and know exactly what you need to put in and what you're going to get out. And that, for me, made creating this app and getting it up and running super easy. So in this case, what do we got here? The search, I believe, is hitting one of these. Yeah, anyway, different. When you're writing a method with TypeScript, I found it super easy to get up and running with an API very quickly so that you know what you need to put in and get out. And so that's one of the things, if you're React especially, that I would recommend when you're starting a new project is kind of the takeaway from this. And then we move on to Angular, and this is where we start to talk a little bit about progressive web apps and why, at least in this area, Angular has a pretty good setup. With Angular 5, which was released a couple months ago, Serviceworkers became part of core Angular, and Serviceworkers, are the things that give progressive web apps some native-like functionality. And so this is where if you're making an app, you want to make it quickly, you don't want to, and you want to make it available pretty much everywhere. The idea is that you create a web application that as more and more functionality is available to your user, you give them more and more functionality, but it will work at the most basic level, at a smartphone, and even with a smartphone that's offline. And that's the progressive aspect of a progressive web app. Service workers are what allow you to have some of that offline functionality. They say if you can't go and make this call or get this index.html or get this JavaScript, here's a cached version that I, as the service worker, have maintained. And so that's what Angular has made pretty easy. In addition to, for a quick app like this, it's really nice to have the material UI components because you can make that mobile first. You can make it first for a phone, and if you saw it still looks
a little bit ugly on a larger screen. So that means that when you are taking what can be just a normal web application made with Angular, you just need a couple files. You need a manifest, which tells the browser that supports progressive web apps, in this case Chrome and Firefox, and excitingly, we'll get to this very soon, Safari. It tells you some of the things about the icons that you need and the name of the application. And then this is the Angular specific file. It's pointing out these are the files that Angular needs to run, or at least to load the first time. And that means that when we run here, which I had done just a little bit ago, a build, the thing that's generated, which we'll pull up, is the JSON that's needed for the service worker, which points out these are the files as of the last update, which is another thing that service workers help you handle. When was the last time this had access? When was the last time this was online? What was the version then? These are the files that you should be pulling. And then this is a complex Angular file specifically to handle the updating of that cache. Good news for React people is that it's pretty easy to write your first service worker and to set up these are the files that I want to be cached, and this is when I want to update them. And that brings us to kind of the final part, which is the progressive web app aspect. It's very much a buzzword, but it's probably most exciting. I think Tony posted in the Milwaukee Slack when it was announced that the primary functionality that makes this work, the service workers, needs to be supported by the browser. It was in Chrome and Firefox for a long time. It was being developed for Edge. And finally, it's available in Safari, which is really cool because, at least for someone like me, I really like the idea of building for the web. And people can choose to consume and go get however they would like. As this comes out and is released on Safari, that means that both Android and iPhone users will be able to visit, for example, my site, and get an indication that this works as a progressive web app. And if you would like, you can add it to your home screen. It will prompt you. If you have Android, you'll hopefully see that. And when you add the icon to your home screen, it launches like it's a native app. It opens up, it gets a splash screen, there's no address bar, it's launched as a separate app, it doesn't count as being in Chrome. And so it's a really cool way, I think, to start things like Ionic and React Native are always like code once, like deploy everywhere. This would be code once and like everywhere would be consuming it the same anyway, so it's already a web app. And so that's what I think makes this pretty cool, and is why I'm excited to keep working on this and add some functionality and make it something that someone can easily visit the site, add it to their home screen, easily reference, kind of like that weather app. And that, unfortunately, I'm sorry about the displays, and I wish I could have shown a bit more of the phone, but I would definitely encourage you to check out the site. Hopefully it prompts you. There is a link. If you want to try the Angular version, it's pretty easy to get started with Serviceworkers/progressive web app. There's lots of great tutorials. Would highly recommend it. And I think that's it. Yeah. Any questions? That was a little fast and a little less code than I wanted to show. Sorry about the screen issues.
Probably my stuff's fault. So.
No, it's Lenovo. They're the worst. Yeah.
So this server workers.
Yes, service workers.
Is that for caching your actual code, or for caching your data, or both?
It can be both. It can intercept API or can intercept network calls, basically. Okay. Yeah. So a great place to use it initially is that, and this could be the one thing I might be able to show. I load this. I have internet. I go on airplane mode, and so if I visit some other site, there's no internet connection. But fingers crossed, it still loads because it's cached. And so that's one place where you can say intercept this network call and use the cache if you can't make that network call. Also works for data.
So do you have those 30 cities cached that you can actually type Milwaukee and it'll come up, or
Right now, no, but it would be doable. Yeah.
Okay.
Yeah. And there's other things. There's already other, like you can cache data in local storage or session storage already. But this helps you organize a little bit and say, especially in times of, they focus on in times of no internet connection, in times of poor internet connection. This will help you kind of manage those situations. Yeah.
That was going to be my next one. So
Yeah.
can you do it on a slow connection? Can you set what range?
I believe so.
Okay,
Yes.
cool. That would be awesome.
And if you can't tell, we're quickly approaching where I won't be able to provide in-depth
No, that's
answers. But yeah, that's something that, especially, so Google is obviously or maybe not obviously, but they've been pushing this initially. That's why it works so seamlessly on Android and why they emphasize having these manifest files so that they know how to treat this as an app. And that's what they mentioned. They want it to be fast, they want it to be reliable, they want it to be usable in poor or no internet connection. Yeah.
Another question. Where did you get that map UI? That was awesome.
I knew
Thank you.
were gonna
That
ask
is
about
so
that.
cool.
Yeah, thanks.
I want to steal that.
Yeah, please. This is open source. And it's just static maps API for Google. So right now I'm getting a new image each time because I like the look of randomizing where the center is. But that's another area where I think it'd be pretty simple to cache. You just say, for Milwaukee, these are the locations. If you already have this image that you've gone out and got from the Google Static Maps API, just use that one as the background. And you can customize how it displays, so I removed a lot of labels and stuff.
All right, one more question.
Yeah.
Back.
Is there a standard for the historical data that you're planning to use?
Standard in what sense? Sorry.
Well, are you going to have to tag everything with a date and a time?
Oh, yeah. So in this case, what I'm getting right now is just the latest data. With OpenAQ, they have a method, an endpoint just for the latest data for each location. And then they also have historical, which they provide timestamps for. So that's what I'll be using, hopefully, to do the comparison graphs between cities, which would go over time. So those have, they're very good at keeping it standardized where they explicitly state this is the concentration, this is the unit, this is the timestamp, this is the geographical coordinates, because they want this to be useful for people like me who spent way too much time writing up a calculation service to make it more viewable, and researchers. So it is quite standardized.
All right, thank you.
Thanks.
Production now for about 3 and some years. Just to give you guys some background, my name's Sam Reed. I'm CTO of the Bitcoin Mercantile Exchange. We're one of the 5 largest Bitcoin exchanges in the world. We do financial derivatives on top of Bitcoin with leverage from 1 to 100 times. And which, as it turns out, Bitcoin pretty big. You might have heard of it. Things have gotten kind of weird lately, to say
It's
the
that
least.
Litecoin, man. Litecoin.
It's that Litecoin, it's that Dogecoin, it's that Spank coin, it's that Tron coin. It just never ends. Basically, like if you were to write a book parodying this point in history, you wouldn't even come close to reality. So this is kind of where we are right now. So I don't want to talk about that. I want to talk about my computer going to sleep. Thanks, Apple. You're the best. So let's talk about a little bit about React. So those of you guys who live in React land know that things have changed a little bit lately. And major kudos to the React team for figuring out how to change things from under your nose without destroying your applications. It's kind of like the modern version of Linus Torvalds, never break user space with Facebook's move fast and break things. If you combine those two philosophies and actually produce something usable, it would be React. They do a beautiful thing where every couple of minor versions, or what they're calling them now, major versions, they deprecate and then remove functionality. They add new functionality all the time. They add them under unstable flags, or you will be fired, don't use this flags. They're great. They do a really great job of it, and like I said, we've been running production React for over 3 years and have not had any major breakage that entire time, and very little that we can actually. Should I not have said that? I should not have said that. She's right.
It's down right now.
That's true. Actually, I kid you not, true story. I was on a plane once with one of my co-founders, and we were sitting there thinking, you know, it's been a really long time since the site's gone down. Like, I've been feeling really good about how we've been architecting things. And we land, and hell is broken loose. And that's actually how you know you should keep some employees, because they handled it. They did a great job. Everybody was fine. Like, things were, you know, we were walking a mile through Bangkok airport on the phone yelling at people, but everything was cool. Anyway, I'm digressing. React does an exceptional job of bringing you from place to place and bringing you from API to API without breaking your applications. And a major thing they did, it's been about 1.5 years in the works, is the migration of the reconciler. The reconciler is how you take the tree that you create, the virtual tree, also known as the VDOM, the virtual DOM, which consists of your own components. Say your layout, your panel, your buttons, those kind of abstract components that wrap DOM elements, how you merge that into what's really displayed on the DOM. And the magic of React is that you don't have to worry about how to get from one state to another. The framework does that for you. And it figures out how to make it fast. And it's in that reconciliation aspect of React that the real performance gains can be made and the really kind of groundbreaking work can be done. And it's a hard problem. A lot of people trivialize JavaScript as a toy language where nothing serious is going on, and some of that may be true, but the reality is there's some serious engineering work being done by these teams at Facebook, and they've done an incredible job of it. The Fiber refactor that we saw was phenomenal. Basically what they did, in layman's terms, you can imagine every single component you create in React as creating a child with some number of sub-children, and you render the children, open them up, render the children, open them up, render the children, back and forth. And you can imagine, like, if you were to debug it in your Chrome debugger, you'd end up with some giant stack, back and forth, back. And if you ever profiled React 15 or before app, you'll see these deep stacks in it. I'm sure some of you guys are familiar with flame graphs. They look like little mountains, where you can see time on the y-axis and the stack depth on the, time on the x-axis and stack depth on the y-axis. It's immediately obvious whenever you see a React pre-16 app, because the stacks are unbelievable. Our production app, which we'd usually go about 40 or 50 components deep, we get stacks so big that it would actually break the Chrome debugger, and half the stack would show up on the next line, and it was totally unintelligible. That's all fixed. The problem with rendering everything as stack is that it's uninterruptible. You cannot pause execution when you're doing that. You have to go all the way down, you have to finish it, you have to go all the way back up. So the main insight that they had was, let's take all that work, let's put it into a structure where we're basically taking everything that's in the stack and we're putting it into a series of data frames that they call fibers. And rather than, say, going deeper and deeper into the stack, you're redefining and serializing all these things into basically a series of arrays where you're deciding what's all the work that I'm going to do. Let's iterate through that work. And that's really powerful, even though it may not seem as such, because you can interrupt that work, you can parallelize that work, you can do all kinds of new, beautiful things with that work. So the original design goal for React 16 was to do what they call async rendering. That actually did not ship, unfortunately. But their original design goal was to interrupt rendering every 16 milliseconds, 16.6 being the magic number, that's 60 frames per second. So right around 15 milliseconds, you'd stop, say, I'm done, let the browser paint, then get back to it. And the idea is you could maintain a really smooth 60 frames per second UI when there's actually way more work than that to be done. And then they have this whole concept of high priority and low priority render targets. Hasn't been done yet, eventually will come. Really exciting stuff. But one of the kind of wacky things that happen with React Fiber that not a lot of people paid attention to is that you can render multiple children out of an app, out of a component. So used to be you always would have to wrap things in a span if you wanted to return multiple children. Now you can just return an array. And one of the side effects that kind of fell out of that was this concept of rendering to a subtree, also known as portals, also known as magic. So portals are this beautiful sort of thing. Just to give you kind of an example, something you might want to do. Let's say you've got a form somewhere, you've got a submit button on it, and when you submit, you want to pop up a modal that says, are you really sure you really want to do this dumb thing that you're about to do? Yes, no, right? And when it comes to normal HTML layouts, there might be something in your layout that prevents that from really being something you want to nest that deep in your tree. You've got something that's absolutely positioned or fixed position, whatever. You've got to get it all the way to the top of the stack. You've got to screw with Z indexes. I don't know how many of you guys have like twiddled the Z index on an element hoping that it will do something and it never does, right? So the canonical solution to that is to put all of your modals all the way at the end of the document. Render them there, make sure they're on top of everything, screw with CSS, everybody goes home, everybody gets a paycheck, and everything feels really good. So what is now possible in React 16 that was not quite possible in React 15, although, spoiler alert, it actually was, but it was an undocumented API, is to translocate part of your tree somewhere else in the DOM. So if you're looking like in the React Dev Tools where you've got your big long tree that's getting deeper and deeper, part of it can actually be somewhere else. This is really useful for modals. This is really useful for a lot of things. I don't really want to put code on this thing because it's bad. It's cutting off half my screen and I don't want to screw with it too much. But I do want to share with you guys a little technique that I got clued into from a Medium article that made it somewhere, and then really kind of hit a nerve with me in terms of some of the things we're trying to do. But it explains this technique a little bit. So this is our trading dashboard. You can see some of it, not all of it. But as you can see, it's a whole bunch of widgets and things. All over the place. We've got a little grid layout here, all these panels, and you can imagine in the old stack sort of layout inside React, some of these things like this little globe icon or whatever, where about 20 layers deep. But we've got all these different widgets. They're all rendering independently. Hopefully someday we'll be able to define some of them as high priority, some of them as low priority. A lot of cool things you can do. But in this kind of widgetized sort of desktop style layout, one thing we've always wanted to do is to pop some of these widgets out to be individual browser windows. Because what's more powerful than that? Why should we rewrite an entire windowing toolkit when we're living inside an OS that has a windowing toolkit? So why can't we do that? And as it turns out, through kind of a poorly documented feature of React 16, we can create a component that we can, by the way, this is live, so I'm sorry if there's any expletives on here. There aren't. That's fair. We can actually put the render output of this thing into a portal. And that portal can actually render to a new window. Little known thing inside a lot of JS apps, not a lot of people are doing it. You can open a new window via window.open, and because it's the same origin, because you fully control it, it still shares the same JavaScript rendering context, it just has its own document. And what we can do then is make the render output of our React component inside that document, and then start screwing around with it. And believe it or not, events still work if you massage it right. Click events, key events, everything still works in there. You have to screw around with styles a little bit because your new document won't have style sheets, so you've got to transplant your style sheets into it. But the effect is really striking. I hope this works. This is actually our testnet site, which is live, testnet.bitmix.com. But if you click this full screen button here, there we go. That same widget, exactly as it was, living inside a new window. There we go. And this has everything. So we've got events, data loading, all that data is loading in the mainframe and being translocated into this widget. And even events, so I can say, hi guys. And people are going to think I'm really excited about this thing. I can even say, I don't like this guy. This guy swore on our chat box. I don't like that. And I can delete it. And all of the API calls, all of the things that we built into these widgets in the first place still work even though I'm in an entirely separate DOM tree right here. And there's a couple of things to keep in mind. One is, notice the URL bar, testnet.bitmax.com/popout. That is a dummy container that just contains an empty DOM. But the point of it is that normally as you're developing your components, you might load an image or a script or something like that using / as the root, normal thing to do. If you render a completely empty container, like about blank, it won't have any context. So images, things like that, you know, fancy little BitMEX logo, hey, there it is, like that little thing, they won't load. So you need to have some context with it. Even if you're just filling it up with garbage afterwards, you still need to have it. And then you can listen to events on this window. You can listen to on before on load, things like that. And if I close it, it comes right back, right in the UI. So you can go back and forth, back and forth, and there's no HTTP calls being done here. There's no WebSockets being open. There's no anything. It's relying on the parent frame as a host. When the parent frame dies, it will die. When it dies, it knows, the parent frame knows about it, and you can build a whole UI toolkit around that. It's a great thing. I highly encourage you guys to check it out. If you're on the Milwaukee Slack, I posted a link to some of the tools that we're using for this. There's somebody who's created a reusable component for this called React New Window. It has some issues. I've got some PRs on it around key events, boring things like that. But basically it's usable, and you can toss it in your apps if you have a use for it. And it's a really cool thing to investigate if you really want to do something different, or you want to investigate a little bit more about how React works and so on and so forth. So that's all I've got. Thanks a lot, guys.